All right, good day, students. On this clip, we're going to be going over the application of De Moivre's theorem. So let's go ahead and write down his theorem first. De Moivre's theorem. Okay. So for this one, it says that if you're raising a complex number in polar form, let's say it's provided to you in rectangular form, it has to first be transferred into polar form, which is you're raising the complex formula. The polar formulation of this complex number rectangular form is r cosine theta plus I sine theta. So this is just the polar form. So if you're raising a complex number in rectangular form to the nth power, the same thing as raising its polar formulation to the nth power. And the formula tells you that all you do here is you raise the radius or the absolute value to the nth power. This goes to a power of the radius times cosine of the angle times n theta plus I sine the angle times n. Okay? Alright, so how is this the case? Remember when we talked about multiplying? The power is repeated multiplication, right? When you're multiplying, you multiply the absolute values and add the radius, okay? When you do repeated multiplication, it's the same thing as exponentiation. R, n times is the same thing as r to the n. And repeated addition is multiplication. So theta 1 plus theta 2 plus theta 3 n times is n theta. Okay? So that is why this formula came to be. Alright, so this is De Moivre's theorem for you. Alright? Now let's apply it to an example. Example 1. Find 3 minus there's 3i to the 5th power and write your answer in rectangular and polar forms. In rectangular and polar form. Okay, so this is what we're going to attempt to do. So first of all, let's apply the theorem here. So what it tells us is we need to convert, in order to use De Moivre's theorem, you have to first convert it into its polar form. This is rectangular, so let's convert this number into polar form. Okay, so convert to polar. Alright, so how do we convert to polar? We need to find r and theta. Alright, so let's find r and theta to convert to polar. So r is basically the square root of a squared plus b squared. So the square root of a squared plus b squared, so square root of 3 square plus negative root 3 square. Remember, don't take the I, okay? So that's going to become the square root of 9 plus 3 times root 3 is 3. Becomes the square root of 12. If you simplify that, this is the same thing as 2 root 3. Because this breaks out to 2 2's and a 3. And then you have 2 root 3. So that's r. To get theta, as a consequence of SOHCAHTOA, you do the inverse tan of b over a, or y over x. You can call this VA, call this xy. Negative root 3 over 3. Let's see, if we plug that in our calculator, let's see what that yields. We'll plug in our calculator, inverse tan of negative root 3 over 3. Root 3 divided by 3. What is that? Negative 30 degrees is our answer. So our theta is negative 30 degrees. So basically the polar formulation of the question is going to be as follows. Instead of 3 minus, so 3 minus root 3I to the fifth is basically equal to bracket 2 root 3 cosine negative 30, put that in parentheses, cosine negative 30 plus I sine negative, plus I sine negative 30, plus I sine negative 30. Raised to what power? We're raising that to the fifth power. So that whole business raised to the fifth power. Okay? Now we're ready to apply the Moivre's theorem. Alright, so we're going to apply the Moivre's theorem. So all it says is that you distribute the power, you take the power and make it a power of the absolute value of the radius, and you multiply it by the angles, okay? So what does that look like? That's going to be 2 root 3 to the fifth power, cosine negative 30 times 5, plus I sine the same as 30, negative 30 times 5. Okay? So that's basically what you have. Alright, what is 2 root 3 to the fifth power? I don't know. Let's do that on the side. So what is 2 root 3 to the fifth power? Is basically 2 root 3 5 times, right? I can use some advanced methodology for this, but let me do it by hand so that you all can see what's going on. So 2 root 3 times 2 root 3 times 2 root 3 times 2 root 3. 5 times. So if I do that, I have 2 times 2 times 2 times 2 times 2. 2 5 times is 32. Times root 3 times root 3 is 3. And then root 3 times root 3 is 3. And then that stays on its own. So it's times 3 times 3 times root 3. Okay? If we multiply that out, that comes out to 288 root 3. 288 root 3. Alright? So the absolute value of this complex number is 288 root 3. And then if you multiply these angles, you're going to have cosine negative 150 plus I sine negative 150. These are degrees. Okay. So guess what? We have our answer in polar form. Okay, this is a polar formulation of our answer. But the question asks us for polar and rectangular form, so we're going to have to compute what the value of this is in rectangular form. So before we do this, are we going to use a calculator or do this by hand? Well, we need to check, is 150 on the unit circle? Let's see. 150 is on the unit circle, so we have to do this by hand. So let's figure this out. What are the coordinates of not just 150, we're doing negative 150 this time, right? So negative 150 gives me the coordinates. Let's see what it is. Negative 150, if this is 150, negative 150 means that we reflect downwards. Alright, we're going to reflect downwards. Let's see. Alright, so negative 150, let's look at negative 150 on the unit circle. This is 150, so negative 150 we just reflect straight down. Remember, negative angle as a reflection downwards, right? So this is right down to 210. So negative root 3 over 2 and negative 1 half are the coordinates we're going to be using. So let's apply that here for 150. So negative 150 is going to be negative root 2 over 3 over 2, comma 1 half, negative 1 half. Remember the x coordinate is cosine and the y coordinate is sine. So we're going to put that in here. So we're going to have 288 root 3 times negative root 3 over 2 plus minus 1 half I. Minus 1 half I, okay? So we just distribute this 288 root 3 to both of these numbers right here. For the first one, I'm going to have 288 times 3, because root 3 times root 3 is 3, divided by 2, minus, this one is going to be 288 root 3 over 2 I. Okay? So 2 goes into itself once, 2 goes into 288 144 times. Same story here, 2 goes here 1, 2 goes here 144. 144 times 3 is 432. I'm missing a minus, and then this is minus 432 minus 144 root 3 I. Okay? So there you have your answer in rectangular form. Okay, so this is polar, and this is my rectangular form. Okay, so there you have it. Now we're gonna try an example involving the principal root. Okay, but before we write that down, let's write down what the rule is. What is the formula for finding the principal root of a complex number in rectangular form? All right, so let's write down the formula first. So principal nth root formula. Principal nth root formula. It's an extension of De Moivre's theorem, so very similar, only that we'll be taking roots in this case as opposed to powers. So the formula is as follows. It says the principal nth root of a complex number a plus bi is given by, so let's say we're gonna take it to the pth root, so it's gonna be a plus bi. Let's say we want to raise it to the nth root, 1 over n. Okay, that's gonna be equal to the complex number in polar form, which is r cosine theta plus I sine theta raised to 1 over p. So in this case, this is what the formula is going to be. Remember the Moivre's theorem, you raise the absolute value to the power. That's exactly what you do here. You raise the absolute value to the p. Oh gosh, what did I use p? N. We're going to raise the absolute value to the nth root, and then we're going to multiply each angle by the root, theta times 1 over n. Okay, it's exactly the same as the Moivre's theorem, only the difference here is that it's a reciprocal, it's a fractional multiplier or power that we're using here. Okay, so theta times same story 1 over n, like that. Okay, so this is what the principal root formula is. It's called principal because there are other roots. By the fundamental term of algebra, we know that the amount of complex roots is the same as the amount is the same as the roots, right? So if you're looking for nth roots, you're gonna have n complex roots. So the principal one is just the first one. Later on, we're going to do learn how to find the other roots. Okay, so we're gonna apply this to another example. Example 2. Write this down. All right, so let's do this. We're gonna find the principal root. Find the principal root. Find the principal root. Principal cube root. Cube root of 2 minus 2I. Okay, so let's do this. So we know what cube root is, right? Cube root is the third root, so we're going to apply it here. In order to apply it here, as the formula indicates, it needs to be expressed in polar form first, and then we can apply the formula. So let's find this. Let's express this number in polar form. Okay. We need the absolute value, which is the square root of the sum of the squares. X squared plus y squared, or a squared plus b squared. So it's 2 squared plus negative 2 squared, which is the square root of 4 plus 4, which is the square root of 8, and that reduces to 2 root 2. Okay. Now the angle, the consequence of the inversion of TOA, inverse tan of y over x, or negative 2 over 2, or b over a, this is b is a, is going to become the inverse tan of negative 1. We plug that in our calculator. Let's see what it gives us. Inverse tan of negative 1. Inverse tan of negative 1 is negative 45 degrees, so it's equal to negative 45 degrees. So let's rewrite this problem. The problem is 2 minus 2I to the cube root. What's cube root? 1/3, right? Remember, the top is a power, the bottom is a root. So this problem in polar form is going to be absolute value of the radius 2 root 2 times cosine negative 45 plus I sine negative 45. What are we raising this complex number to? We're raising it to the 1/3 power. Okay? So we have it in a formulation that we can apply to De Moivre's theorem, right? So all you do is raise the radius to the power and multiply the power by the angles. And that will give you the polar form. And then we'll use our other tools we have to express it in rectangular form, okay? So let's do it. So we're going to go 2 root 2 raised to the 1/3. Raise that to the 1/3 times cosine negative 45 times 1/3 plus I sine negative 45 times 1/3. Okay, close that, close that. Okay, what on earth is this 2 root 2 to the 1/3? This is a complicated problem, so let's do that on the side, okay? What is root 2 as a fractional power? Since the root is 2, that means the denominator is going to be 2. So we're going to, 2 root 2 is basically 2 times 2 to the 1/2. 1/2 power is root. And this power is 1, okay? Any number without a power is 1, okay? So what is 1/2 plus 1/2 plus 1? 1 plus 1/2, let's do that. 1 plus 1/2, put this over 1, times this by 2, top and bottom. Well, we could do this thing, okay, this is 3 over 2, right? 1 plus 1/2 is 3 over 2. So 2 root 2 is the same thing as 2 raised to the 3/2 power, right? Exactly the same thing. So I can replace 2 root 2 with 2 to the 3 over 2. So let's put that here. 2 to the 3 over 2 raised to the 1/3 times cosine negative 15. If I multiply these two, negative 15 plus I sine, let me write that, that 15 looks weird. Negative 15 plus I sine negative 15. Okay? Alright, so if I multiply these two together, 3/2 times 2, the 3's and the 3 cancel out, so you're left with 2 to the 1/2, right? 2 to the 1/2 cosine negative 15 plus I sine negative 15. If I want to express the 1/2 as a root, what is 1/2 as a root? This is the power that's the root, so this is basically the square root of 2, right? Square root of 2 cosine negative 15 degrees plus I sine negative 15 degrees. Now this is your answer in polar form. So this is the polar formulation of your answer. Alright? That's your polar form. But we also have to express it. I want you to express the answer in rectangular form also. Okay, so how do we do this? Negative 15 on the unit circle, then we can work from there. If it's not, then we have to use our calculator, okay? Alright, let's see. Negative 15. There's no negative 15 here, so we have to use our calculator to figure this one out. So I'm going to be lazy. I'm going to plug everything into the calculator directly to reduce the chances of making mistakes. And then we'll get the final answer. So I'm going to go square root of 2 times cosine negative 15, close that, plus I sine negative 15, close the 15, close the cosine and sine, enter, bam, that goes the answer. So the answer is going to be, it's going to be an approximate answer, 1.366, so it's going to be approximately 1.366, oh, 366, can't even write anymore, 1.366, minus, just use the left arrow, it gives you the other ones, minus 0.366, okay, minus, minus 0.3660, okay, sorry, so there goes your answer in, polar, in rectangular, okay, so there goes polar, and this goes rectangular, alright, so there's the answer. Alright, thanks for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure.